Yeah, so basically in this problem we are given two arrays a and b, and in one operation you can either add 1 to I or double all the elements of a. You are supposed to convert a into b using the minimum number of operations possible. So now the first thing that comes to mind is convert them into their binary. Like for example, I have a 2 and I want to convert it into 18. So like something like this. So now the thing is that what we can do is we can first of all we have to calculate the limit, like how many times can I double every element. So for example, consider this one, or no, let me consider a better test case. I'm sorry. Let's say this one. So in this one, 2 can be multiplied by 8. That makes it 16. If I multiply it again, it will become 32, which is greater than 18, which we do not want. So it can be multiplied with 8. That is 3 operations. Okay. 3 can be multiplied by 4, and so on. You get the idea. Basically, I am multiplying by 2 to reach the floor of this. So this one will be 3 operations. This will be 2 operations. This will be again 2 operations. This will be again 2 operations, and this one will be again 2 operations. So we see that the limit here is 2. Now that gives me the threshold, basically, that I can only multiply by 2 I can only multiply all the elements of the array twice. So that's my limit. Now what happens when I multiply it by 2? So 2 square, that is 4. So 2 becomes 8, 3 becomes 12, again 2 becomes 8, 5 becomes 20, and 1 becomes 4. Now this is the maximum amount of doubling that I can do. So the array basically becomes 8, 12, 8, 20, and 4, and I'm supposed to convert it into 18, 13, 10, 30, and 7. Now I can store what is called a remainder, like even after doubling, how much I need to still add. Okay, so the remainder here is 10, the remainder here is 1, the remainder here is 2, the remainder here is 10, and the remainder here is 3. Now the limit, our limit was basically 2. That implies 4, like 2 square. We can only multiply by 4 at most. So notice that if my initial number was suppose a and I multiplied it by 2, it becomes 2a, and a plus 1 times 2 becomes 2a plus 2. A plus 1 times 4 equals 4a plus 4. In other words, when I add a 1 in the number before doubling or quadrupling it, when I add a 1, it also gets added to the answer twice or 4 times. Like basically, if I add a 1 earlier, it is profitable to me because eventually I will add twice to the number. If I add a 1 here before multiplying it 4 times, I can actually add 4 to the remainder. So obviously the best strategy is greedily choose it. Like for example, I have 10, so you can before doubling it twice, you can actually add it. You can actually add 1 twice, because 2 times 4 is 8. So what I'm saying is, divided by 4, you can add a 2, the remainder becomes 2. Now you can divide by 2, add a 1, remainder becomes 0. In other words, before doubling, so suppose my number was 2. Before multiplying it 4 times, add a 2. Add twice. Now it becomes 4. Now you multiply it by 2, it becomes 8. Now you add another 1, it becomes 9. Now you multiply it by 2, it becomes 18. These are the minimum number of operations that you can perform. So I actually have already written all the operations and remainders for this test case, which you can notice here. So we had to convert 5 to 100. So the limit was 4, that is 2 to the power 4 is 16. So I multiply every number by 16. These are the remainders, and so on. I can actually calculate. Now we are also supposed to answer the number of ways in which I can perform those operations. So like, this is the minimum number of operation, like you require at least 17 operations, but how can I arrange those 17 operations is this number basically. So it's actually very simple. You just have to keep track of what was this number basically, the modulo, the division, the floor division. So suppose the remainder was 20. Suppose the remainder was 20 and I divided by 16. So the floor division is 1. It means before multiplying by 16, I have to add once. I have to add 1 once. So you can keep storing it. You can make some array of store, and like you can store of 4 will be 1, plus then here it's 3, plus here will be 11, and so on. So the total comes out to be, for example, for the 2 to the power 4 case, it comes out to be 20. And individually you can also store all these numbers. The number of permutations will of course be 20 factorial upon 11 factorial, 3 factorial, 4 factorial, 1 factorial, 1 factorial, and so on. Answer, you just have to multiply and you're done. So that was the intuition of the problem. What I was not initially able to understand was this thing basically. This is a very important caveat for solving this problem. This is basically the key to solving this problem, that when should you add a 1. So you can think of it as a greedy strategy.